Hello. So what we're going to do today is we're going to talk about these things called literal equations. So literal equations are just equations that have multiple variables in them, right? So these are the ones that you'll often see like in science class or like in geometry especially. They'll come up quite a bit. You know, they're a formula where you've got a couple different numbers going on, but you don't know them yet, so you use a couple different variables, right? And what we're going to do is we're going to write them in like equivalent forms, right? We're going to be kind of moving stuff around to get an equivalent formula. That's when you got two or more formulas. When you write them a little bit differently, right? Variables in a slightly different spot, but they'll result in the same answer, right? And when I say in a different spot, that doesn't just mean like, oh yeah, swap where the x plus y is, right? It means that we're actually moving more stuff around in the equations, right? So let's just jump right in. So the way that these problems are set up, right, it says solve this equation for x, right? When it says for x, that means that I want to get the x by itself, right? So in this case, the x should be the only thing on its side of the equal sign, right? So just like any other equation, like what I've been doing, right? If you like putting that little divider down the middle, we can do that. And again, I want to get this x all by itself. So that y that's next to it has to go away. So don't get freaked out because it's a y. All we need to do is just treat it as if it was kind of like a number, right? If this was x minus 7, we would say, oh yeah, plus 7 and move it over, right? We're going to do the same thing. We're just going to say add y to both sides, and that's going to get rid of it. Now, when we add it to the other side with the 13, right, I'm just going to say plus y. But then it's this next step where, especially as we get used to these, we might make a mistake. Right, so we've got the x by itself on that part. That's all good. But then on the other side, we've got negative 13 plus a y. So what I'm here to tell you is this is not, I repeat, this is not going to be negative 13y. That is not it. Right? What we need to do is we just need to say, all right, negative 13 plus y. Right? I don't know what that is because I don't know what y is, but that's all I need to do is just tack it on to the end. Right? Cool. That's our answer. X is by itself. Right? We don't even need to go any further than that. Right? Let's try another one out. Right? Again, we're just thinking about trying to get that x by itself. And again, my biggest hint, or I guess helpful tip might be treat the other stuff like just numbers. Right? Sometimes they're numbers that you can't smush together like negative 13 and y. Right? But if you just treat them like numbers and move stuff around, it might work out pretty okay. All right, so on this one, we are going to have a little bit more to do. I want to get the x by itself. So these y's are going to need to go. So I'm going to start by moving those 9 y's to the other side. All right. So when we subtract 9y from each side, they are gone on that side. We're left with just a negative 3x over there on the left. On the other side, again, don't do just 18 minus 9. Right? It's not going to get us where we want to be. We want to have this as 18 minus 9y's, right? They're different types of terms. We cannot combine those. All right, so after that, we only got one more thing to get rid of, right? We need to get rid of that negative 3 that's on the x, right? And remember, this is not a situation where we want a plus 3. This is a situation where we need to divide by negative 3 to get rid of that, right? When I do that, I've got multiple things on the other side. I want to take each one of those and divide it by negative 3. Right? So when we do that, right, what's going to happen is this. Those negative 3's next to the x are gone. We're going to get just x, which is good. That's what we're looking for. Over on the other side, we do need to do whatever, kind of division will work out nicely for us. It's okay to leave things as fractions, but if it comes out as a whole number, we really should do that. So right up in the front there, 18 divided by negative 3 is going to be negative 6. Right? After that, we've got negative 9 divided by negative 3, which is going to be positive 3 with that y still attached. Right? And that's what we're looking for, negative 6 plus 3y. All right. So what I'd like you to do is actually pause here, try out number 3. It's pretty darn similar to the one we just did. Right, and remember, if you're not sure or if the division doesn't come out nicely, it's okay to leave it as a fraction. So if I gave that a shot, this is what I had for this one. I moved my x's over because, again, I got to be a little careful. I'm solving this one for y. right? So you got to pay close attention to what it's asking for. So I moved my x's over to the other side. I then had to divide by -2 to get that away from the y, and then I had to divide each of the other things by -2. When I do that, 100 divided by -2 gives me 50, and then -5 divided by -2, right? These two negative signs are going to give me that plus sign there. But then 5 over 2, I'm just going to leave as 5 over 2, right? It's going to be 2.5, right? You could write that as well, right? But leaving it as a fraction is fine too, right? Let's try another one out, right? Again, important thing is to keep an eye on what it is that they're asking for. I want to solve this one for y. So that y needs to be by itself. All right, so on here, same kind of deal to start off. I'm moving those x's over, so we're going to add 6x to both sides. All right, you might notice that when I'm adding 6x over on the right-hand side, I kind of put it off to the side here, right? It's not directly underneath the 24. I kind of put it a little bit scooched over. That kind of reminds me that when I write out this next line that we're on, that it's not 24 plus 6. It's separately 24 plus 6x like that. All right. After that, we got to divide by 3. You know, pretty similar to the ones we were just taking a look at. Because again, I want to get that y all by itself, which it now is. 24 divided by 3 is 8, and 6 divided by 3 is 2 with an x on it. All right. And again, that's what we're really going for, right, is we're just moving some stuff around, you know, treating things like numbers, albeit numbers that cannot combine like these ones, right? So other than that, then we're good. So taking a look at the last couple on here, then they start to look a little bit more, you know, challenging, right? But what I'm going to tell you is that they're not all that much worse. They just look worse, right? So something like this. Again, it's good to keep an eye on what it is that I want to solve for. This one I want to solve for n. So I want the n all by itself. On this one, the n is kind of tied up in those parentheses and everything else. So it's kind of like a puzzle, right? It's like, what do I undo first to get that by itself, right? And one thing that can be kind of helpful is think about it as kind of like layers, right? This n is what we're looking for. Then look at the next closest thing that's going on, right? The next closest thing is that we've got m plus n, right? And then the next furthest thing out from there is the 3 on the outside of those parentheses, right? And then think about it like you're kind of like unwrapping this, right? You need to start from the outermost layer to get to the inside, right? So the very first thing I'm going to start by getting rid of is that 3 that's multiplying out there, right? So again, the 3 is multiplying, right? Normally we'd say, oh yeah, let's distribute and all that, right? But in this case, we just want to get rid of it. So what we're going to do is we're just going to divide that whole chunk by 3 and divide by 3 over there as well, all right? So when we do that, these 3's cancel each other out. Over on the left side, whatever b divided by 3 is, that's exactly what I want to write. I can't figure it out because I don't know what b is, but b divided by 3 is just as good. After we got rid of the 3 on the right, now we just have m plus n. Right? And then I just need the n by itself. So if m and n are adding to each other, I'm going to do the opposite and subtract m to get rid of it. All right? And again, this is one where, you know, it looks kind of messy, right? So it's good to keep track of things. On the left-hand side, I have b divided by 3, and then we subtracted m from it. So I'm just going to write it exactly like that. Over on the right-hand side, we have just n, and that's what we're looking for, right? We're trying to get n by itself, and so we did, right? So again, think about it like, again, you're kind of like peeling through some layers, right? It's like an onion, right? And we're trying to get to that innermost piece, right? Let's take a look at another one. Want to solve, this is the density formula if you weren't sure. Density is equal to mass divided by volume. And we want to solve this for m, right? So this is one, you know, that like comes up in science class, right? It's useful to be able to solve for different variables depending on, you know, the pieces you already know. So if I want to solve this for m, that means the m needs to be by itself, right? So to do that, again, think about undoing whatever's happening with it. In this one, we have m divided by v. So to undo division by v, I'm going to multiply by v. Right? So when we do that, I'm again doing it on the other side as well. We're going to yeet the v's right out of there. Over here, we're going to have v times d. On the other side is just m. Right? We can write it exactly like that. Sometimes you'll often see people just kind of abbreviate the multiplication as putting them next to each other like that, right? That is a very common thing, so it might be a good idea to get in the habit of writing it like that, but v times d equals m, that's right above it, is also fine. Right? And we're actually like getting pretty close to the end, right? What I would challenge you to do is maybe try this one out. If you want to pause here and give that a go, that's fine. I am going to talk through it from scratch because it is a little tricky. All right, so same kind of deal here, right? We want to solve this. It's actually the same exact equation. We want to solve it for v this time, right? So again, keep a close eye on what you're solving for. Now to get that v by itself, I kind of want to get it out from the bottom of that fraction. So our first step is actually going to be the same as what it was on the last one. Right, I'm going to multiply by v to kind of move it around. Right, so when I do that, again, the v's cancel out from the fraction. We have vd over here equals m. Right? After that, I want the v by itself. So that means that we need to get rid of this part where it's multiplied by d. So to undo that, I'm going to divide by d on both sides. Right? And again, just like before, as it works with all sorts of numbers and fractions and everything, these cancel out on the left. We get just v. And then what's m divided by d? I don't know. I'm just going to write it down that way, right? There's no way for us to figure out what that actually equals because we don't know what the numbers are, right? But that's all I need to do is just divide them like that and leave it that way. Right? So then one that's going to come up in geometry quite a bit is the circumference of a circle, right? And we are solving this for r, or for, if you want to say it that way. So to get r by itself, again, we got to think about what else is happening with it. So we have c equals 2 pi r. And remember that when you've got multiple things kind of next to each other like that, there's a little tiny bit of multiplying going on in each of those, right? So to undo that multiplication, I'm just going to divide, right? What do I need to divide by? Well, it would be helpful to divide by anything that's not r, right? We can do it all kind of at the same time. So if I divide by 2, it'll get rid of the 2. If I divide by pi as well, it'll also get rid of the pi, right? When I do that, again, I need to make sure I do the exact same thing on the other side, keep everything nice and even. And what's going to happen is that now that I've divided by 2, the 2's cancel out. Same thing with the pi's, they cancel out. So all I have over on that right-hand side is just r. Over on the left side, I'm just going to leave it exactly as it looked up above, right? C divided by 2 pi. And that's it. Right? So even though this looks really scary and it's like, oh my God, there's so much stuff going on, I don't know what pi is, right? Just treat them like numbers, right? I mean, 2 is a number, pi is technically a number, and you just get rid of them, right? Think about what's going on. How do you undo it and get rid of it, right? Oh my. So again, don't be freaked out. This one looks worse than it's going to actually be. On this one, we want to solve the volume of a cone for h, right? So to get h all by itself, right, again, we're going to need to do a couple things. Think about first what's going on between all of this stuff, right? Right now, this is 1/3 times pi times r squared times h, right? And again, I want to get the h all by itself, so all that other stuff needs to go, right? So there's a couple different things that you could do. There's one that's probably the best way to do it. Then there's one that's a little bit, hand-wavy kind of magic, like, sure, I guess we can do that. So we'll talk about the hand-wavy way first, right? So don't write this down quite yet. But one thing you could do is you could literally just divide by 1/3 pi r squared on both sides. That will technically work. However, the better way, the way that's going to kind of set you up for more success in the future, is to think about, this has got a fraction in it. the very first thing we wanted to do with fractions was get rid of them. So to get rid of something where it's 1 divided by 3, I'm going to instead multiply by 3 on each side, right? When we do that, right, what's going to happen is that this 3 over here, and I'm going to do it in blue so it stands out a little better, cancels out that 1/3 over there on the right-hand side. Over on the left, we've now got 3v equals, and this is pi r squared h that's left over, right? Now this is where it's going to be a little bit better to divide by pi and r squared on each side, because then you don't have a fraction in the bottom of a fraction, right? Which is kind of like a whole big mess. All right, so what's going to happen here is that those pi's cancel out, the r squareds cancel out. What I'm going to have is exactly what it looks like. 3v divided by pi r squared equals h. And that is it. That's all we need to do. And by all we need to do, I mean, it was a couple steps, but you know. All right. And then last but not least, we want to solve the surface area of a sphere for r, right? So again, real close eye on what you're solving for. I want to get the r all by itself. And this one's going to have a step that might be new to you, right? And that's okay, right? It's going to seem a little like, yeah, I don't know about this, but it really does work out. It's all right. So to get r by itself, there's a couple things, right? We know that we have 4 times pi times r, so we can get rid of those by dividing. But then we've also got r to the 2nd power, right? And that is a little weird. So we're going to worry about that in just a second, right? Let's get rid of the 4 and the pi first. So again, just like on some of the other ones, to get rid of 4 and pi that are multiplying with r, I'm just going to divide by 4 pi, right? So if you got something that's being multiplied, you want to get rid of it, divide by whatever it is, right? Because what's going to happen is that those 4's cancel out, and so do the pi's. All right, so now we've got a divided by 4 pi equals r squared, right? And we're real close to being done, right? That squared does need to get off of the r, right? We need to get rid of that. So when you have something that's squared, right? Like say that we had, and again, just off to the side somewhere, say we had x squared. What that really is it's x times x, right? And there's a way that we can undo the squared part, right? So the way that we undo something squared is that we use the square root, which looks like that, right? So what happens with a square root is that if you put something in there that is squared, but you take the square root of it on the outside, it's just going to undo the square root, right? So that's exactly what we're going to do here, right? I'm going to take the square root of r squared, and I'm going to take the square root of a divided by 4 pi, right? Which again sounds pretty awful, right? And what we're really just trying to do is get the r all by itself. So over on that right-hand side, it undoes the square part, and we get just r. Over on the left side, I don't know what the heck that's going to be. So what we're going to do is we're just going to write it down exactly like it looks. A divided by 4 pi, all underneath a square root sign. And that's our answer. Right? We don't get to go, we don't even need to go any further because I don't know what those other numbers are. I don't know what a is. And taking the square root of 4 pi is not something that we really need to do, right? So again, the whole idea behind a lot of this is just treat them like they're numbers, right? Just think about what's going on and then do the opposite to cancel them out and move them over. When you do move things over, right? When we did a divided by 4 pi, I didn't spend, a whole bunch of time thinking about like, oh man, what is that? I just wrote it down as a divided by 4 pi, right? I didn't think about what the square root of a divided by 4 pi was. I just wrote it down and that was our answer, right? So don't get freaked out by these. There's a lot going on to keep track of, but if you just work slowly and keep track of it, then that's probably the best thing you can do, right? As is, that's it for now. So I'll see you next time. Bye.